Right, let's take a look at the first question. So they want us to find the ones digit. Right. So we take the ones digit of each number. These are all digit 2. Right. This will be digit 2 minus 2 times 5. There are 5 numbers after the first one. So we get, right, this is only the last digit. So 2 minus 2 times 5 is 10. So the last digit of the number is a 0. 2 minus 0, so we get 2. The answer is B. Now, the second question, just do a direct calculation. 44 divided by 11, which is 4. Right. Second one, 110, 44. They have a common factor of 11. Let's divide by 11, so we get 10 over 4. For the third number, let's divide by 11 first, so we get 4 over 100. So 10 divided by 4 equals to 2.5. Now 4 out of 100, we can convert it into decimal, 0.04. So the answer is 6.54. We choose option C. Now question 3. So we can find the shaded area by finding difference of the squares. First, we use this square. This is 7 times 7. Minus the small square, which is 4 times 4. We find this part. 7 square minus 4 square equals to 33. Next, we can find the other shaded region. We use the big square, 10 times 10, minus the second largest square, 9 times 9. Difference give us a shaded. So 10 square minus 9 square. This part is 19. Now just add them together. 33 plus 19 is 52. So we choose option E. Now for question 4. So we have added the integers from 1 to 9. First, we can find the sum from 1 to 9. The sum equals to 45. And she left out one number, so the sum of the remaining 8 numbers give us a square number. Then we need to find a square number that's less than 45. So that's 6 square. This square number is 36. So difference between them give us a number that she left out. Now 45 minus 36. The number is 9. So we choose option E. Next, for question 5, the product of the two numbers is a multiple of 6. So let's check. If the product is 6, then it can be 1 times 6, or it can be 2 times 3. Now the first group, 1 plus 6, the sum is 7. So we can get 7. Then second one, 2 plus 3 equals to 5. We can also get 5. Then let's try if the sum of the product is 12, it can be 2 times 6, or it can be 3 times 4. 2 plus 6 is 8. So we are able to get 8. 3 plus 4 equals to 7. We are able to get 7. Next, we can try the product equals to 18. 18 can only be 3 times 6. So 3 plus 6 is 9. We can get 9. The only one that's not achievable is 6. We choose option B. Now let's take a look at question 6. They want us to rank the 4 paths from the shortest to the longest. Now let's try for P and R. So the only difference is that this part, for P, this is a curved line. For R, this is a straight line. We know that between any 2 points, the straight line is the shortest. Okay. So first we know that R is less than P. So we got R followed by P. The other two are longer because this is a triangle. And you can see that these two lines added together is longer than this line here, which is what we have in the path P. So Q and S, they are more than P. Now let's compare path Q to path P. To compare between them, just check this part. Compare to this part. There's half of the one in the middle, right? The other side is the same. So we just need to compare which one is longer. Now, obviously, path Q, this is longer. Because for path S, this is in the middle. So that's a shorter line compared to what we have here. So S is less than Q. Let me choose option D. Then question 7, find the minimum number of 1 by 1 tiles. So for the 2 by 2, we can get at most 3 of them. That's 1, 2, 3. Then for the 1 by 4, we can just get 1. Right. The rest of them will be the 1 by 1. There's 1, 2, 3, 4, 5. 5 of them. 当然是 C. Let's take a look at question 8. Now, on Monday, Tay has $2. So every day afterwards, he either gains $3 or double the amount. How many different amounts are there after 3 days? Let's just list down all the possibilities. Now, if we do addition for all 3 days, so 2 plus 3, this is 5. Plus 3 again, this is 8. Then 11. This is the first way. Then we can try do addition twice and then do multiplication once. So let's say we do the multiplication first. Double the amount, 2 times 2, this is 4. Then plus 3 equals to 7. 7 plus 3 equals to 10. Next, we can plus 3 first, 5. Double the amount, 10. Plus 3 again, 13. Next, we can plus 3, 5. Plus 3, 8. Double the amount, 16. Then we can check the case where we do addition once and multiplication twice. So double the amount twice. Right, let's say we double the amount first, 2 times 2, 4. 4 times 2, 8. 8 plus 3, 11. These two are the same. Alternatively, we can do 2 times 2, 4. Then 4 plus 3, 7. 7 times 2, 14. Next, we can do 2 plus 3, 5. 5 times 2, 10. 10 times 2, 20. Then lastly, we can try double the amount 3 times. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. Right. So we get total of 8 different cases. Let's check how many different amounts are there. And so we can get 11, 10, 13, 16, 14, or 20. The others are duplicated, so we only count it once. There's a total of 6 different amounts. We choose option D. Now let's take a look at question 9. So Maria has half as many red as the green. And we know that red is 1 U, green is 2 units. Then twice as many blue as the green. So the blue is 2 times 2, 4 units. This gives us a total of 7 units. And then which of the following could be the total number of marbles? So the total is a multiple of 7. Let's check. Out of the 5 options, only 28 is a multiple of 7. 28 is 4 times 7. And the answer is E. Now, question 10. This started from 1980. It continued all the way to 2030. That's 50 years later. So for 50 years time, every year increased by 1.515. Let's find the increase. 50 times 1.515, that's 75.75. So the starting value is 338 plus 75.75 is equals to 413.75. They want us to round it to the nearest integer, so there's 414. We choose option B. Right, let's take a look at question 11. So to give us the coordinates, right, this will be in Cartesian coordinate. So you get the y-axis and the x-axis. Okay. Then these numbers, so the first one is referring to the number on the x-axis. The second number is referring to the number on the y-axis. Right. Anyway, we just need to know that here, this one between 5 and 11, the difference is 6. This means that AB is 6. Then we look for the height. Right. This one is y, this is 7. So the difference between them is y minus 7. That's the height. And it says area of the triangle is 12. So we know that the base times the height times half equals to the area. There's the height times 3 equals to 12. So the height equals to 4. Now the height is y minus 7. So y minus 7 equals to 4. And y equals to 11. So we choose option D. For question 12, so we can check the first fish tank. Let's say the number of guppies is 1 U. In the second tank, there's one guppy more than the second tank, more than the first tank. So 1 U plus 1. 2 more guppies in the third tank. So on top of 1 U plus 1, then plus 2, there's 1 U plus 3. For the last tank, 3 more guppies plus 3, so this is 6. 1U plus 6. Right. Total number is 90. Let's add them together. 1U plus 1U plus 1 plus 1U plus 3 plus 1U plus 6 equals to 90. That's 1U, that's 4U plus 10 equals to 90. So 4 units equals to 80. 1U is 20. In the fourth tank, there's 1U plus 6. So that's 20 plus 6 is 26. So the answer is E. Question 13. So we have a sequence of 6 steps. Each time is either up or down. But we know the first one, it must be up. Because at first it's on the level ground. So cannot go down, so it must be up first. Then the 4 moves, these 4 hops, it can be up or down. The last one must be down. It must be at this step, and then you go down at the last step. The last one is down. First one is up. So we can only change those 4 in the middle. Because it ended on the ground, so the number of ups and the number of downs are the same. You can see we have 3 ups and 3 downs. So in the middle, we have 2 ups and 2 downs. Right. There's 4 hops. Out of them, we choose 2 of them to be going up. The other 2 are going down. So that's 4C2. That's 6 ways. But out of the 6 ways, now one of them is impossible. This is a case where you have up, down, down, up, up, down. Because when you go up, go down again, it's below the level ground. That's not possible. So we need to do 6 minus 1. The answer is 5. We choose option B. Now, question 14. Let's look for the shortest route. So you can check that if go from A to M, there's 8. But if it's A to X to M, the 5 plus 2, that's only 7. So we choose this route instead of A to M directly. Next, we can see that in this part, this turn, there's only 6. So we are going to choose the 6. And you check from M to C, there's 6 plus 5, 11. There's a 14. So we choose the 11 instead of 14. Then compare these two, 17 and 10, we will choose 10. Let's just add them together. 5 plus 2 plus 6 plus 5 plus 10 equals to 28. So the answer is 8. Now let's take a look at question 15. So we have 8 times the 6-digit number fly fly equals to the 6-digit number buck buck. This 6-digit, right, equals to the first 3 digits times 1001. And then this 6-digit is also equals to the first 3 digits BUG times 1001. So we cancel out the common factors. Right, we are looking for a number 8 times fly equals to buck. And they also want us to get the greatest value. So we know that this 3-digit BUG is a multiple of 8. Now, the largest multiple of 8 we can get is 992. But 992 cannot be used because these 6 letters, they all represent different digits. These are distinct digits. We cannot have repeated digits here, so 992 cannot be used. So let's do 992 minus 8. That's 984. Let's see if it works. So 984 divided by 8. This equals to 123. So this works. You see all the digits are different. 1, 2, 3, 9, 8, 4. The different digits. Let's just add them together. 123 plus 984. The sum is 1107. We choose option C. Now, question 16. So we put the numbers from 1 to 81 into the 9 by 9 cells. They want to find the least number of rows and columns that could be have a product divisible by 3. So when the product is divisible by 3 means that particular row or column contain a multiple of 3. Those rows and columns that are divisible, they must contain a multiple of 3. So first, let's try how many multiples of 3 are there. To do this, we can just use 81 divided by 3. We have 27 of them. So we have to check how to arrange these 27 numbers. Or we can try put them into 3 rows where each row have 9 numbers. Those 27 numbers. These 27 multiples of 3. You can see we got 3 columns. Now, these 3 columns, they are divisible by 3. Then each column have 9 numbers. So those 9 rows, they are also divisible by 3. Okay, this is 3 plus 9. That's 12. Or we can try arrange them into 4 rows. Right. Then we must use 4 times 7, that's 28. Right. So we have 4 rows. The first 3 rows got 7 numbers. The last row will be there's one blank. The last one is 6 numbers. So the 4 columns, then when you check the rows, that's divisible by 3, we get 7 of them. Because each row here have 7 numbers. Okay. So this is 4 plus 7. That's 11. The last way to do it is you arrange them into 5 rows or 5 columns. Each column will get 6 or 5. Is 30 numbers. Okay, everything within the 5 by 6 rectangles. Then we get 5 columns, 6 rows. That's also 11. So the smallest value is 11. We choose option D. Question 17. So the question want the white king and the black king to be separate. Let's check 2 cases. Case 1 is when the first king, let's say we start from the white king, is at the corner. Right, so we got 4 corners. Let's check each of them got how many ways. Suppose we choose the top left corner. So the second king cannot be surrounding the first king. We cannot choose these three positions. You can only choose one of the rest. There's 1, 2, 3, 4, 5. Those are the possible positions. Then for the other corners, it's the same. Let's say you choose the top right corner, you also have 5 ways. There are 4 corners to choose from. That's 4 times 5. 20 ways. Then let's try case 2. Case 2 is when the white king is at one of the edge in the middle. One of these 4 squares. Let's say we choose the one on top. So the black king cannot be surrounding the white king. These positions cannot be used. Then we only have 3 possible positions. There are 4 edges to choose from. Each of them have 3 ways. It's 4 times 3. 12 ways. So we can get a total 20 plus 12 equals to 32. We choose option E. Let's check question 18. So first we find area of the smallest circle. The radius is 1. So that's pi r squared, pi times 1 squared. That's just pi. Let's find the first ring. And there's a difference between the medium circle and the small circle. So that's pi times 2 squared. Area of the medium circle minus pi times 1 squared. The area of the small circle. This equals to 3 pi. That's the difference between them. Now, for this part, the question says that the shader equals to the unshaded. So to find the area, we can get the total first. The area of the big circle is pi times 3 squared. This is 9 pi. Half of it is 4.5 pi. So the shaded area is 4.5 pi. The unshaded is also 4.5 pi. Then we can find that this part will be 4.5 pi minus 3 pi. This is 1.5 pi. Then for this part, we can also get the area. Let's just use the total minus everything else. So 9 pi minus 3 pi minus 1.5 pi minus pi. This is 3.5 pi. Let's compare these two. The shaded to the unshaded. We find the simplest ratio. We cancel the pi times 2. This is 3 to 7. Then we will know that the angle at the center, it follows the same ratio. This is 3u. The angle on the other side is 7u. We can let the angle be, we'll draw another figure. This angle is 3 units. The angle on the other side, this is 7 units. So the sum of them is 360 units. Then we get a 10U equals to 360. 1U is 36. The angle we are looking for is 3U. That's 108. So the answer is 8. Now, question 19. So let's draw a table. So in terms of the color, we have red and white. Then the total. Then we have the high top and the low top. Then the total. In total, we have 15 pairs of sneakers. Total number is 15. Then it says that 3/5 of them are red. The rest are white. So 15 times 3/5 is 9. So total number of red sneakers is 9. White will be 6. Next, 2/3 of the pairs are high tops. Then we find the high tops will be 12 times 2/3. This 10. So the low top is 5. We want to get the least possible number for the red high top, which is the number here. Now, we know that the total number of red is 9. And next thing we know is for the red low top, the most we can get is 5. Because for this column, the total is only 5. So this is the largest we can get. This part is maximum is 5. Then the other one will be the minimum. That's also 5. This is 0 and this is 5. Sorry, this is 0 and oh yeah, this is 4. Yeah, 9 minus 5. Okay, and this is 6. Right, let's get the fraction. So the red high top is 4. Total is 15. 4 out of 15. The answer is C. Question 20. So we want to form equilateral triangles. And one of the vertices is point P. Right. So to make equilateral triangles, we have to use the diagonals of the square surface. And from point P, we have 3 diagonals. This is the line PT, and then the line PR. Then the last one is the line PV. These are the diagonals of the square surface, and they are of equal length. And we must contain 2 of them to form the equilateral triangle. So if we contain PR and PV, then we can form this triangle PRV. You can see all 3 sides are of the same length. Next, if contain PT and PR, the one will be RT, the one on the back surface. So they are also of the same length. There's also an equilateral triangle. That's a triangle PRT. Then lastly, contain PT and PV. You see, TV is the diagonal of the bottom surface. They are of the same length. There's an equilateral triangle. So that's the triangle PVT. In total, we have 3 of them. The answer is D. Let's take a look at question 21. So it says at first, the number of green frogs to the number of yellow frogs is 3 to 1. We let it be 3U, 1U. The total is 4U. Now, in the end, the ratio is 4 to 1. Some of the green becomes yellow, then some of the yellow becomes green. Let's say 4U, 1U, the total is 5U. So the constant should be the total. Total number remains the same. 4U and 5U, we look for the LCM, that's 20. So everything on top times 5. Everything below times 4. We make it into 15U, 5U, 20U. Then below we have 16U, 4U, 20U. Now let's check for the changes. So it says that 3 green frogs becomes yellow, 5 yellow frogs becomes green. So afterwards we have 2 more green, plus 2 for the green, minus 2 for the yellow. So we can find that 1U is 2. Number of green frogs changes from 15U to 16U. 1U is 2. Now they want us to check the difference between the green and yellow in the end. So 16U minus 4U equals to 12U. U is 2, so 12 times 2. This is 24. We choose option E. Now, for question 22. So this roll of tape is wrapped around the center. And so the shaded part refers to the tape. It says that this is 0.015 inches thick. So now we can just assume that these different circles wrap around each other. So for simplicity, we'll say that these are the circles, layer after layer. And let's check how many layers are there in total. So we know that this part is 1 inch thick. And the total is 0.015. So let's do 1 divided by 0.015. We get the number of layers. That will be, if you leave it in the fraction form, that's 200 over 3. And that's around 66, 67 layers. Okay. Now, for each layer, we'll know the circumference will be different. The outer layer's circumference is larger. Inner layer's circumference is smaller. So we find the average of their circumference. The average will be the one right in the middle. Yeah. So to find it, we can use the circumference of the big circle plus the circumference of the small circle. Then after that, divide by 2. There will be 4 pi plus 2 pi over 2. This average circumference is 3 pi. So now we assume that all the layers, the average circumference is 3 pi. We can find the total. We use the number of layers, 200 over 3 times 3 pi. That gives us the total length. That's 200 pi. Now we know pi is around 3. Okay, this is 3.14. So the total is 200 times 3. This is 600. We choose option B. Question 23. So we draw a line connecting these 2 points. Okay, let's label them. The one of the point is 2,000, 3,000. The other one is 5,000, 8,000. Right, so we can construct a rectangle. Then they say that we connect this line here. Now how many cells will he color this time? Well, let's find the length of the rectangle. This is 8,000, this is 3,000. Difference between them is 5,000. This side equals to 5,000. Then let's find the breadth of the rectangle. There's 5,000, 2,000. Difference between them, that's 3,000. So we need to cut them into smaller units. Like the one shown in the figure is contained in this rectangle. So you cut them into two smaller units, which of them is 1 by 2. We are going to do the same. So we have to check the highest common factor of the length and the breadth. The HCF is 1,000. So we cut them into 1,000 units. Now, each of them, okay, so we get smaller units here. Right, so we cut them into smaller groups. I won't draw all of them, so this is just to show you how we cut them. So we get 1,000 groups, and then we know that 5,000 divided by 1,000, this is 5. 5 units. The other side will be 3 units. So we just need to check for a 3 by 5 rectangle. Now, how many small squares does it cut through? So let's draw the figure. Three columns, 5 rows. Right, so when we connect the diagonal, this will cut through the 2 from here. Now, 3 in the middle, and 2 on top. There's 7 of them. So for each group, we have 7. All right, we got 1,000 groups. There's 1,000 times 7 equal to 7,000. The answer is C. Question 24. Right, these are two right angle and isosceles triangle. They overlap with each other. So let's get the triangles. Okay, to find the shader part, so we use the area of this triangle, that's the first one, plus area of the second triangle. Then after that, minus overlap. So let's check for the first triangle. Now we can cut in the middle, so that's 2 triangles. And you can move one of the triangle to here, so it becomes a square. Okay. This becomes a square, so area of the square is 8 square. For the other triangle, we can do the same. Cut in the middle, then we move this triangle to here. So again, it becomes a square. This is 12 square. So in the middle, this one, we can move the triangle to here, cut in the middle. So make it into a small square. The set length of the square is h, so this is h squared. Minus the overlap equals to the area, which is 183 square feet. Just work out the value, 64 plus 144 minus h squared equals to 183. From there, we can find h squared is 25. So h equals to 5. The answer is B. Now, the final question. So there are 4 rows of seats, and we already have 8 passengers. They have boarded the plane. So we check the total number of ways here. Now let's just say the 8 passengers, they are indistinguishable, right? They all look the same. Then it will be 12C8. Okay, this is because it doesn't matter, because even if you do permutation, eventually the 8 factorial cancel each other, right? Because when you check the remaining number of possibilities, you also need to check that if they are different, you times 8 factorial. So now let's just assume that they're all the same. So we choose 8 seats out of the 12 for the 8 passengers. Now 12C8, this is the same as 12C4. So we work out the value. This equals to 495. That's the total. Now this question will be easier if we check the opposite, the exceptions where the married couple is able to sit next to each other. So we consider these 8 passengers first. The first composition is we have 3, 3, 2, 0. Means one of the row have 3 passengers, another one is 3 passengers. The next row is 2 passengers, the last one is 0. Total is 8 passengers. So let's say this is the case. Now for the one with 0, the couple, they can always find 2 seats next to each other. So this one is 0 exceptions. This is none. For all the scenarios here, the couple, they can sit next to each other. Next one. It can be 3, 3, 1, 1. Now, when this is the case, so those 2 rows that's fully occupied, we don't have to consider them already. Let's only consider these 2. So most of the case, the couple, they can get 2 consecutive seats. The only exception is that you choose those 2 in the middle. If these 2 are occupied, now the married couple, they cannot sit next to each other. So the only exception is when these are the middle one. Yeah. Those 2 passengers, they choose to sit in the middle, like this. Now the couples, they cannot sit next to each other. Okay. Let's check how many ways are there. So this one is that out of the 4 rows, select 2 of them to have 3 passengers, the other 2 have 1 passengers. That's just 4C2. There's 6 ways. Next, the composition can be 3, 2, 2, 1. So those with 3 passengers or 2 passengers, those cannot, the couple cannot sit there. So again, it comes down to the 1. If we choose the middle seat, so the couples, they cannot sit next to each other. So the only exception is when the 1 is sitting in the middle. Then again, we check the number of ways. Right, first, we have to check And so we select which one is the 3. This can be any 4 of them. That's 4C1. Then we choose which row is 1 passenger. This is 3C1. After that, the remaining 2 rows, they have 2 passengers. Then after that, for the one with 2 passengers, we have different arrangements. It can be the first 2, or it can be the first and the third. It can be a second and a third. So each of those with 2 passengers, we have 3 different arrangements. So times 3 for each of them. Yeah. You got 3 different arrangements for the one with 2 passengers. So altogether, this is 108 ways. Now, the last scenario is that each row have 2 passengers. When this is the case, the married couple can never sit next to each other. So we already discussed that if we have 2 passengers, we have 3 different arrangements. First 2, first and the last, second and the last. So this is 3 times 3 times 3 times 3. 3 to the power of 4, 81. All right, let's check how many exceptions are there. This is 6 plus 108 plus 81. These are the cases where the couple cannot sit next to each other. That's 195 of them. Then we check the remaining. So 495 minus 195. 300. So if 300 outcomes, the couple can be next to each other. So we use the desired outcome over the total 495. Simplify it. This is 20 over 33. So the answer is C.